Hello everybody, and welcome to Project 4 Video 4 of my engineering project series. And in this video, we'll be going over my Bluetooth remote control car project, which is definitely my favorite project yet, mainly due to its complexity from the connecting of the HC05 Bluetooth modules, as well as from the need for precision in the 3D modeling, make sure that all the components of the car are able to fit into the body of it. And so anyway, with that, show a brief demo of the project, and then an in-depth breakdown of the whole process behind making this project. So with that, enjoy. So now we'll be going over all the components for the project. And so first I'll be going over all the components for the remote and then after the car. So first for the remote, we have an Arduino Uno. We have an HC06 Bluetooth module configured in child mode, 4 push buttons, 4 resistors that connect with the push buttons, a breadboard, and then an Arduino USB cable. And that's all for the remote. And now for the car. First we have an Arduino Uno, 2 L298N motor drivers, 2 6V battery packs. Then we have 4 wheels that correspond to 4 DC motors, which are custom bought, and all links to the parts will be in the description. And then we have 3 sets of 3 jumper wires soldered together to get rid of the need for a breadboard. These all hook up to the motor drivers, which will be shown later in the video. Then we have 2 pin-to-pin wires, and then we have 12 pin-to-hole wires. And then lastly, we have 1 Bluetooth module configured in parent mode for the car, and that's all for the components. And so here's the circuit for my project. So we'll start out with just the car. So we have our 4 DC motors, both hooked up to individual L829N motor drivers right here, which then are hooked up then to the Arduino Uno. And this Arduino Uno has a battery pack hooked up to it here. And then there's an extra battery pack right here to provide extra voltage to the 2 motor drivers. And in a second, I will connect those and show a demonstration of the circuit working together before we get into the final assembly of the project. But anyway, for our remote, we have our HC06 module, then of course for the car too. And then we have our 4 push buttons right here, each with a 10k ohm resistor connected to the ground, and then connected to the digital pin, a wire connected to each button. And then basically, when something is clicked, this battery pack right here connects to this remote, which then will allow this Bluetooth module to send a signal to this module, which then goes into the Arduino Uno, and it reads what letter it is, which will break down more in the code of the project. But basically then, depending on which letter it is, it will tell all the motors to spin in a certain way, either clockwise or counterclockwise, and this motor driver does it for the motors on the corresponding sides. And anyway, besides that, one more important thing is, since I didn't want to use any breadboards in this project so I could keep the car as small as possible, I did some soldering and connected a bunch of wires together that were 5V, allowing this Arduino Uno to power the 5V pins for the 2 motor drivers and the Bluetooth module. And this just saves space, so I didn't have to make the car too big, so there wasn't too much weight on it. But then anyway, besides that, now I could hook up everything and then show a demonstration of the circuit. And so now, after we've connected the last wires, we could tap the buttons and it will move the car in the corresponding direction. And this is pretending that we have wheels already connected to it, but all of the motor axes already spin in the right direction. It's kind of hard to tell. So So that's about it for the circuit. So now we can get into the 3D printing and the code and the CAD and then the final assembly. So now here's the code for the project, and we'll start off first by going over the code for the remote and then after the code for the car. So first we have our serial.begin 38400. This initializes serial communication for the Bluetooth modules mainly, and this 38400 is just what works best with the HC05 Bluetooth modules. And then we set these 4 digital pins to input so they could go into reading mode. So if there's a high voltage detected on one of them, then the corresponding signal will be sent to the other Bluetooth module to tell the car to move forward, backward, right, left. And this is just basically what I talked about before. So if pin 10 is high, then it sends a F through the Bluetooth modules, and then 11 backward, 12 R, 13 L. And then also I was having an issue where the car would like jerk right, left, forward, or backward, because too many inputs are being sent and the Bluetooth modules would get overwhelmed. So this helps minimize that by delaying everything by 200 milliseconds every iteration. And so anyway, that's about it for the remote code. So now we can get into the car code. And so to start off, first we have our motor 1, 2, 3, and 4 terminals initialized with each 1 digital pin each. And each of these digital pins from the Arduino Uno is connected to the inputs of the motor drivers, which in then turn controls each of the motor's terminals, which allows us to go have a dual H-bridge configuration for each of the motor drivers. And anyway, so we have our Bluetooth module HC05 initialization for serial communication. And then now we initialize all these pins to output mode to connect to each motor terminal. And then this if statement right here basically just checks if there's something being sent through the Bluetooth modules, and then if so, the if statement's activated. And then this variable right here is initialized and reads whatever is being sent. And then this right here, we have 4 if or if else statements that read either if it's F, then it tells us that F is received. This is to help me at the start to make sure that everything is working correctly. And then this is through a lot of trial and error. I would figure out which terminals are which, and then which of them allowed me to go forward, then backward, and right and left. And then this is just corresponding. So we have R, then it's supposed to go R, and then it waits 200 milliseconds. And this is the same problem where the car would jerk forward too much, or right or left or backward or whatever, if I didn't put this delay here. So this helped solve that problem. And this also just looked smoother in general. So this was obviously the configuration for our right spin, left spin, and then go forward, go backward. And then besides that, that's really about it for the code for this project. And so yeah, that's about it. So here is the CAD for my project. And so to start off, first we'll just be going over the car body CAD and then the remote body CAD after that. And so to start off, we just have the car body. So at the top, we have our Arduino Uno mount, and then the 2 motor driver mounts right here. And then each motor driver will be connected to a corresponding DC motor, which will be glued in between these 2 boxes right here. And these are all dimensioned correctly because I measured them beforehand, so I know how this works. And then inside here we have the battery shaft, and we would store 2 6-volt batteries in here, which then their wiring will be funneled out through here. And then this side will most likely be taped up with just duct tape. And then when this wires for the batteries funnel out here, we can then connect them back up to the top to power the whole circuit. And that's really about it for the car body for the CAD. So now we can get into the remote body, which is just about as simple. So we start off with just our layout. So we have an Arduino Uno mount here, a battery shaft right here. And again, we would probably just tape this up to hold it steady. And then we have our battery wiring hole right here to connect it to the Arduino Uno. That would be right here. And then finally, we have our breadboard mount, which is the dimensions here. And then we would glue the breadboard on, and then it could conveniently hook up to the Arduino Uno and allow the whole remote to work. And then also, of course, we would probably put the Bluetooth module in the middle of the breadboard with the 2 buttons on either side of so for the right, left, up, down for the car controls. And then besides that, that's about it for the CAD. So with with that, after printing everything, coding everything, and planning everything out, I completed the project. And so first we'll be going over the car. So off the bat we have our battery shaft, and I ended up putting the battery terminals out of here instead of here because it was hard to filter the battery wires out here. And then anyway, we're able to glue on the motors to each between each blocks right here, and then we were able to test the wheels easily. Then I glued on this motor driver, Arduino Uno, and other motor driver to the mounts as shown in the CAD. And then if we go over here, we can see the Bluetooth module is actually hooked up to the heatsink of one of the motors, or motor drivers right here. And then besides that, also, of course, we have our wiring right here, and everything is hooked up as it should. And I just used a screwdriver. I didn't do any soldering right this for here, but I did do some soldering right here to connect up and get rid of anything that the reason I would need a breadboard for, because I was not able to fit a breadboard on the car without making it too big. And then anyway, though, besides that, that's about it for the car. And then we go over here, so we have the remote. So as you see, we just taped the other Bluetooth module to the middle of the breadboard like I talked about. We have our forward button, backwards button, left button, and right button right here, all hooked up with the 10K ohms resistors, and then digital pins of the Arduino Uno. And then I was able to put a battery shaft in here, and then I duct taped all of this shut. And then we have the battery terminal right here, and then that's able to connect to the Arduino Uno. And also, I didn't mention this, but we have our battery terminals right here. We also charge the batteries. We could recharge them through the terminals, so I'll never actually have to take this tape off to take the batteries out and charge them, since I could just do it while they're still in the application. And so then anyway, besides that, that's about it for our final wrap up. So with that, yeah.